Hello everyone, my name is Katie and I am here at the Imagine Children's Museum to do a Bubbletastic experiment. One of my favorite things to experiment with is bubbles. I hope you like bubbles because today we're gonna make a big bubble. But I wanna make this bubble without using any of my own air. I'm gonna use a very special thing called dry ice. Dry ice is frozen carbon dioxide. So if we breathe in and breathe out, we breathe in oxygen, we breathe out carbon dioxide. So scientists are able to freeze that carbon dioxide that comes out. And it makes this really cool thing when it gets warm because dry ice is below 0 degrees. It is so cold. It's colder than snow. So when it gets warm, it gives off gas, just like our breathing out. So let's see if we can use this really cool gas to make a bubble. Let's get set up for our experiment. So if we were to put a piece of dry ice into our regular bowl of water, let's see what happens, shall we? We'll put on our safety glove and we'll pick up a piece and put it in. All right, what do we notice? I'm noticing that we're getting lots of this mist on top. I'm hearing some bubbling. Remember, all of that dry ice is so cold that as soon as it touches the water, it wants to get warm. And when solids get warm, this is getting so warm so quickly, it's going from a solid to a gas. Now, all of those molecules are starting to move around, they're starting to take up more space, and they're creating the bubbling we're hearing. They're creating the mist that we're seeing. Now, if we're making bubbles, this isn't really making bubbles. So I wanted to try to make one giant bubble using all of the excess gas. Now, in order to do this, we're going to take some of our soapy water here, make sure it's all nice and mixed up, and I'm just going to put a rim of it around the bowl just to coat it. There we go. Now, I'm being very careful to not touch the inside of the bowl with my wet hands because it would be really cold. That dry ice is warming up, but it is still below 0. It is still so cold. Let's take our string, our nice and soapy water-soaked string, and try to make a layer of film on the top of our bowl here to trap all of that gas. There we go. We've made a film on top here. I don't know if you can see, but all of that gas is trying to push on top of it. Whoa, what do we notice? I'm kind of noticing it's starting to dome a little bit. Well, this is pretty cool. We have trapped all of that gas inside. All of the carbon dioxide gas that is bubbling away has been trapped by... What? It popped! There was so much gas inside that the surface tension couldn't keep it in anymore. This is one of the cool things about bubbles. We can make bubbles, but it's way more fun to pop bubbles. Love it. Okay, let's try again here. Get our string nice and soaked in the soapy water. What? I even see a film forming now. And let's try to make a film on the surface of our bowl. There we go. We have a nice film on the top. All of that gas is kind of pushing out. I don't know if you can even see, it looks like almost a mini thunderstorm going on inside of our bowl. All of that gas keeps coming up in different places. We can see the waviness, and I don't know about you, but it looks like it's starting to dome. Let's see how much gas it takes for our bubble to fill up. This is pretty cool. Normally the only way to trap gas is inside of a balloon or inside of you. I know. But we've created another way to trap gas. Bubbles trap gas. Bubbles are just a gas surrounded by a liquid, which is what we have going on here. However, we've made kind of a weird bubble because we have a gas surrounded by, there it goes. It has popped again, all that gas, and I think it's pretty cool that when it breaks, all of that gas comes out. All right, everyone, we were able to make our big bubble without me having to use my breath. We were able to use our dry ice, our frozen carbon dioxide. This was a Bubbletastic experiment, and I hope that you also experiment with bubbles at home. Thanks for joining us today, and we'll see you later. Bye, everyone.